Ice and fire. Tonight, the fire is a star burning at 15 million degrees, and the ice is a planet, a world the size of Jupiter, frozen solid, traveling at 600 kilometers per second toward a direct collision with our sun. What actually happens when the most frozen thing imaginable meets the most energetic thing in our solar system? Stay with me, because the answer involves something that happens to Earth that nobody would ever predict. Before I get to the collision, I need to tell you something about what this ice planet would look like approaching from Earth, because what you'd see in the sky in the months before impact is something no human has ever witnessed. And it's extraordinary. Water is the third most abundant molecule in the universe. A Jupiter-sized planet made primarily of water ice, mixed with methane, ammonia, carbon dioxide, is physically possible in the cold outer reaches of a solar system. As it approaches the sun, the outer layers begin evaporating, creating a comet-like tail millions of kilometers long. A Jupiter-sized comet. Nothing like it has ever been observed. And as it approaches our inner solar system, the sky above Earth transforms. Here's what the approach does to our solar system before anything touches the sun, and why the real danger starts months earlier than the collision itself. This is the part that affects every person on Earth first. The ice planet's gravity disrupts everything in its path. Outer planets thrown into new orbits. Thousands of comets and asteroids sent inward. Earth's sky fills with more comets than any human generation has ever seen. Dozens visible simultaneously. And the ice planet itself develops a coma, a temporary atmosphere millions of kilometers across, visible from Earth as a diffuse glow spanning significant portions of the sky. Then it touches the sun's corona, and everything changes. What happens the instant ice touches the corona is something that violates every intuition you have about what ice does near heat. Because at those temperatures, the ice doesn't melt, it doesn't even boil. Something completely different happens. At millions of degrees, phase transitions become irrelevant. Water molecules don't go from solid to liquid to gas. They go directly to plasma, electrons stripped from atoms. Hydrogen and oxygen cease to be water and become superheated ionized particles. The energy of ionization absorbs some incoming energy, briefly cooling the contact region, before the kinetic energy of 300 Earth masses of material overwhelms everything. The ice becomes the hottest thing it has ever been, in the moment it meets the thing that was always hotter. Here's what the actual collision does to the sun, and why it doesn't destroy it. Because the sun's response to a Jupiter mass impact is something that should genuinely surprise you. The sun is a fluid body. The impact creates a shockwave that propagates through solar plasma. The sun rings like a bell. The impact point is driven inward, a column of compressed plasma pushed toward the core. Solar material rushes in to fill the void. Oscillations circle the entire star. Solar quakes millions of times stronger than any previously recorded. The sun doesn't break, it absorbs. But what it sends back toward Earth is catastrophic. What the sun fires back at Earth after absorbing the impact, that's the moment that ends civilization as we know it. And it doesn't require a direct hit on Earth. It just requires the sun being disturbed. Here's exactly what happens. Coronal mass ejections of unprecedented scale fire in all directions as the solar magnetic field is catastrophically disrupted. Earth receives a bombardment of charged particles, a geomagnetic storm thousands of times more powerful than anything in recorded history. Every satellite fails, every power grid collapses, every electronic device on Earth simultaneously destroyed. The auroras extend to the equator, a sky-filling light show, and this is before any direct effects from the impact itself. The sun's response to being hit by a planet destroys our civilization through electromagnetic shock alone. Now here's the long-term consequence. What the impact actually changes about the sun permanently. Because a Jupiter mass of water ice doesn't just hit the sun and disappear. It changes what the sun is, and that change affects Earth for thousands of years. A Jupiter mass of water ice adds hydrogen and oxygen to the solar composition. Additional hydrogen extends the sun's lifespan slightly, but the oxygen participates in a different fusion pathway, the CNO cycle. which runs faster than the sun's normal process. The sun burns hotter and brighter after the impact, a temporary brightening affecting Earth's climate for thousands of years. More energy reaching Earth, more heat, a warmer world for centuries, as the solar composition equilibrates. And here's the final consequence. Something that affects the night sky above Earth for thousands of years after the impact. Something beautiful, emerging from something catastrophic. The volatiles from the ice planet that didn't fall into the sun distribute through the inner solar system as a diffuse cloud of gas and ice particles. Earth passes through this cloud periodically, creating meteor showers of unprecedented intensity. For thousands of years after the impact, the night sky occasionally lights up with meteor storms that make the Leonids look like scattered sparks. Beauty emerging from the most violent event in solar system history. And here's the thought that puts all of this in context, because we've already watched something like this happen, not to the sun, to Jupiter, and the images are real. In 1994, comet Shoemaker-Levy 9 broke into 21 pieces and slammed into Jupiter over 6 days. The impact scars were larger than Earth, visible in backyard telescopes. Each fragment released energy equivalent to hundreds of nuclear warheads, and that was a comet the size of a small mountain. What we explored tonight was a planet 300,000 times more massive. The universe already runs these experiments. We just have to be watching at the right time. And increasingly, we are. The universe runs experiments we couldn't design in a laboratory. And every time we look carefully, we find something that changes our understanding of what's possible. That sense of discovery is what this channel is built on. Subscribe right now, hit the bell. Share this with someone who loves space. Every week we explore something new. And the next destination is already being built. See you in the next one.